Cuando ponga. Vale.
Well, hello. My name is Pedro Herruzo Sánchez, and it is the first time I will talk to you, so please don't expect too much. Today, I will talk about this paper, leveraging context to support automated food recognition in restaurants. And these are the contexts that we'll see today. Let's start with this. First, I wrote some data that authors thought that it is interesting for us. It is that in 1970, 25.9% of the people spend time eating away from home. And by 2012, it was 43.1%. So the tendency was increasing. And they say that 80% of the people, of American people, they eat fast food monthly, and the 40% of the people eat fast food weekly. Therefore, obesity, nutrition, and chronic diseases are now a major health concern. And logging eating habits are increasing to prevent these diseases using diaries and smartphones. Manual tracking they say that it's time-consuming, prone to errors, and it is susceptible to selective underreporting. In fact, it's shown that fat people, they underreport what they are eating. Let me summarize first the contribution of this paper. And they develop an automated workflow where online resources are queried with contextual data, location, means the GPS, to find images and additional information about the restaurant where the food picture was taken, and with the intent to build classifiers for food recognition. For classification, they use this sequential minimized optimization multiple channel learning, multi-class SVM, with features extracted from test photographs. And for testing, they use in the wild pictures taken from 10 different restaurants across 5 different cuisines: American, Indian, Italian, Mexican, and Thai. They did a comparative evaluation focusing on location information of the images. So they will compare how it works using the GPS data and how it works without using it. As a system overview, they say that the acquisition of the food images are using food gun worker, Instagram, Pinterest, Philip. But what I understood reading the paper is that they just use Google image search. They determine where the picture was took using longitude and latitude coordinates and APIs like Yelp or Google Places. Once they determine a particular restaurant, they search online for the menu of the restaurant, and then they take every item of this menu and they find 50 images for these items with Google image search. The test data is formed by segmented images from a certain restaurant R, and as this system overview could seem a little bit difficult, let me explain you with a picture. And I will do a little bit of spoiler of later slides, but I prefer to explain it with pictures than with text. So what they did, first of all, is build the training data set based on the information of the taste data set. How? The test data set is built by 3 people who will go around 10 different restaurants across 5 different cuisines. So at the end, they will have 10 different restaurants, right? And what they do is with the GPS data from the image taken on that restaurant, they will look where the restaurant is using latitude, GPS data. And once they have which restaurant it is, they will look for the menu of this restaurant also online, because there are some pages which give you this menu. And then what they do is they took from each restaurant just the 15 most rated dishes of this restaurant. And with these 15 dishes, they find 50 images per each item. So this will be the training data set that is based on the test data set. And then after that, they will have a weekly labeled training data, and then they build the classifier. And yeah, this is the system overview.
So what?
Yeah.
Why?
Yeah, okay. The weekly labeled is because once they have the dish, so once they have the menu restaurant, they download the 15 most rated dishes. And this is the weekly label, because they use this label to search in the image Google search. Okay. 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 For the classification problem, first they need to define which features they will use, and they focus on illumination change, because images taken in a restaurant are typically indoor and under varying conditions. Thus, they will use color descriptions. And first of all, as a feature extractor, they will use this Harris Laplace point detector. And after that, for feature description, they will use 6 kind of these. 2 of them based on color. This is the 2 first one: color, movement invariance, and hue histogram weighted by saturation. And then they use the 4 different scalar invariant feature transform for different shifts. And after that, they will classify as follows. For a given restaurant R, 100,000 interest points are detected. And then for each of the 6 descriptors I already told you in the previous slide, they build a back-of-word histogram using k-means with k equals to 1,000. So they will reduct this 100,000 interest point to 1,000, and then they will compute the extended Gaussian kernels. It is built with these 2 equations that we have on the right side, and this equation works like that. So the first one is the extended kernel Gaussian, and it took as an argument 2 histograms, the I and J, and they built the exponential of the distance of these 2 histograms. And this distance is built with the second equation, that it just took every element of the first histogram and subtract another element of the other histogram. And in fact, when you will compute the kernel of one histogram with itself, you will get the value of 1, because in the second equation we can see that we are subtracting each element of the same histogram, so it will be 0, and then the exponential of 0 will be 1. Just a detail. And then they will use this, they will perform a linear combination of these 6 kernels by using this sequential minimal optimization algorithm with a p-norm p greater than 1. What I read is that they use this p-norm greater than 1 because with the 1 norm, it is not differentiable, then they found troubles, so they decide just to do it with a p-norm greater than 1. Then they use SDM to classify the images. Okay. So as a picture of what I already explained you, I built this. So they have the 100,000 point detections, and they built a back-of-word histogram cluster of size 1,000 for each of the 6 descriptors. And then they compute these extended Gaussian kernels. As I already told you, the diagonal is the elements of the kernel extension of one histogram with itself, so it will be 1, and the other side, no? And well, now I will talk about the evaluation. And first of all, so don't look at the slide now, because first let me explain you what they do. They have 2 different evaluations. One, they will evaluate how this multiple kernel learned classifier works using these 6 different descriptors with an already built dataset, the PFID. And then they will do an evaluation with in the wild pictures taken with these 3 people over the 10 restaurants. So let's start first about with the PFID dataset. So this dataset is built with 61 categories of fast food images acquired under lab conditions. And each category contains 3 different instances of foods with 6 images from 6 different points of view in each instance. So it means basically that, for example, if you are working with spaghettis, you will have 3 dishes of spaghettis. And then you will do for each of these spaghettis 6 images from different points of view. So at the end, you will have 18 pictures of spaghettis. Okay? Then they do these 3 cross validation, 12 out of 18 for training, and the remaining 6 for testing. Doing that, in results that we will see in the next slide, the multiple kernel learned gives the best performance and improves the state of the art by more than the 20%. And they note that the SIFT approach achieves 31.9 accuracy, where the SIFT used in the PFID achieves 9.2 accuracy. And they also explain why. I will tell you now. These are the accuracies. The 2 first columns in green are the one from the authors. So as you can see, they're not that good. And the second 2 columns in red are 2 methods that the authors of this paper also used, but they don't explain how. And the rest 7 columns are the 6 descriptors I already told you, and the multiple kernel learned from these 6. So the last one is using the 6 descriptors together, and it is the one that achieves better results. And what they say is that they SIFT, compared with the SIFT that they built, is pretty better, and they explain why. They explain that the authors of this data set, they use SIFT with just the default parameters. And what they did is just tune these parameters, and that's why they also get this accuracy. They also say that they use this chi-square kernel with scale data, but to tune the parameters is what is the best for them. Okay, so after compare the approach of the multiple kernel learning with the 6 descriptors over another data set, now they perform evaluation from the dataset that they have built. So they perform evaluation with the in the wild food pictures. I already told you how they took these pictures, and at the end, they had 600 images taken in 2 phases, 300 images from smartphone, and 300 images taken from Google Glass. I guess in 212, Google Glass was still cool, not now. And in results, well, let me show you the results first. These are the results. And as we can see, the multiple kernel learning is achieving the best results for 4 of the 5 classes. But note that Mexican and Thai food, they have a limited accuracy. But this is not that limited because it's better than randomly guess one of the 15 classes for each cuisine. But they explain why they get these accuracies. And it's because if you look inside the Mexican food or the Thai food, you will see that they have a lower degree of variation intra-class. So it means that even for a person, it will be difficult to distinguish between 2 different classes inside this cuisine. Not for all the classes, but for most of them. Okay, so now they compare as a default evaluation. How is it performing to know the data from the GPS versus don't have the data? So they disregard the location information and they train the SMO MKL classifier on all the training data. And they got that the accuracy over the 600 test images was 15.75. whereas the previous model obtained in average 63.33. Thus, they say that the average performance increased in 47.66 when location prior was included. From what I already know, I guess that if we train using deep learning, using convolutional learning, convolutional neural networks, just having a topology as GoogleNet or AlexNet and fine-tuning from ImageNet, I guess we will have the same accuracy than them or better. But at this point, they are not using convolutional neural networks, so it makes a lot of difference. So they claim that it is better to build several small restaurant using specific classifiers rather than one all-category food classifier. So here I end the talk about the paper, and I will just do one more slide about suggestions and about what I think about that. First, a summary. Finally, they built the training dataset based on the most popular foods for a particular cuisine, matching 15 dishes from the menu of the restaurant where the test data was taken. So they built, in other words, they built the training data with the prior knowledge of the test data. So imagine that in our research, we want to use this approach to get a good classifier for the city of Barcelona. Following what they say, or at least what I understand that they are saying, we should somehow split Barcelona in small regions. And as we will split Barcelona in small regions, in one particular region, we will have not many kind of cuisines. So let's say, for example, 2, Mexican and another one. And this for all the sections that we define in Barcelona. And then we should train a classifier for each of these regions. Okay? As a cons for that, first of all, the user needs to allow us to get the the pictures needs to have the GPS data. So because if the picture has not the GPS data, which classifier will you use? You don't know, so you will choose one randomly, and this can be very bad. And it will be many classifiers. And also we need to find a best cluster for each classifier. So it's difficult. As an alternative, I propose, or at least we were talking about using it. I guess that it would be better to do one all-category classifier weighted by GPS data. And that's what I think. So thank you for attending, and any suggestion or questions?
Well,
yeah.
I have a very silly question, but
and can you speak louder? Because
it's okay, not so smart question, but about GPS.
Okay.
What happens if the restaurant is indoors? Like, how do you actually obtain the satellite position when you're inside the restaurant? Like, there's no satellite here inside.
I don't know. You just need, for me, the question is, I get the image, and I will look if GPS data is in that image with the geotags. If there is not, I don't know. So this is why I prefer to do one all classifier, because then you will use the data, the GPS data, as a weighted. So for weighting. And if there is no data, you will use just the default classifier.
Maybe you can provide it manually.
What?
Or maybe you can provide it manually.
Manually,
Position.
the GPS data.
As you, I mean, if you're using it for training, so you know that at this day, this time you've been in that restaurant. So you can just manually, automatically, some way, but you have somehow the ground truth. You can extract
Yeah, that's
from
true.
somewhere.
But it's true. But then when you will have the test, so in the real life, I don't know how to use it.
I guess maybe what you can do is, in case there's no GPS data, manually, the idea is to get what kind of restaurant is that.
Yeah.
If you just say, instead of getting GPS, looking at the map, you say, okay, I'm in a Thai restaurant, then that makes everything easier.
Mm-hmm.
I mean, just to have this possibility if there's no GPS data.
Yeah.
They said that they segment the images.
What?
They segment the images.
Yeah, exactly. Yeah,
But
listen to the images.
to study the part where there is food.
Yeah. So I don't have here the slide, but in the paper there is a picture where they first segmented the food, and that's the region that they pass to the classifier.
What do they use for segmentation? What do they use for segmentation?
I don't know.
Because
They just say that they are doing segmentation, but they don't say what.
Yeah, because I know that it's not easy to segment.
Yeah, I
just,
know. I know.
About the GPS, well, I think it's pretty useful if you go to have lunch or dinner to a restaurant. But how do you indicate to the system that you are eating in your home? I mean, maybe you could weight your food as if you were in a Mexican restaurant because you've got a Mexican restaurant next to it. So you have to think about that.
Yeah, that's the problem.
So from the table, it seems that for Italian food, another method is much better, right?
Sorry?
From the table,
Yeah.
the side. So the method is the last column, right?
Yeah, exactly.
Yeah, and why for Italian food this other method perform better?
I tried to thought
You
about.
didn't say anything.
Yeah, I didn't say nothing, and I tried to thought about that, but I don't know.
Not better, no?
Yeah, here they are using just the SVM with opponent shift, which this method, I don't know which one is, but it used to be better on that particular cuisine. But they don't say why, and I didn't know that.
Yeah.
And
Sorry, just
Pedro?
fast food.
Yeah, exactly. No, it's not fast food. It's just the picture that these three guys were going across 10 different restaurants. So it's not fast food, this one. The fast food dataset was the previous one. This one.
Okay.
I think Petia was going to ask something.
Yeah,
Hello,
yeah.
Petia, tell me.
That's a question. I think here I like the idea of the multi-kernel super vector machine. I think this is interesting, especially when we have a few images, because they have very few images in order to apply this method, right?
Yes, it's 50 images per class.
Yeah, so it is very good alternative to the deep learning when you don't have so many images. My question is, does it make sense, for example, to apply the k-means on the response of the CNN?
Yes, and then you will use SVM, for example.
Yes.
Yes, you can do that.
That is, if you go back to the transparency,
Yes.
but to construct this.
You want this one or the previous one?
The previous one?
Okay.
The previous?
Previous? This one, you mean?
Okay. When you were explaining about the backwards application. Okay. Here.
Okay. Yeah. Yes. So what you are saying, I guess that it's just to take the previous layer from the softmax. So yeah, let's say, for example, the previous one for the last fully connected, and then use this k-means to just, as weeks ago we talked about this PCA that is reducing the size of your layer. So yeah, we can use it also. Instead of the PCA, we can do a k-means, so a cluster for a given size. Hello.
Okay. Good. Okay.
Thank you. There are more questions?
I was thinking about discussing the discussions.
Okay, perfect. Yeah, and
Well, one thing I didn't understand, you said that you were going to somehow split the city of Barcelona to different regions.
yeah, but this is just if I follow the suggestion of these people.
Yeah, but I just can get how it could be helpful, because you cannot say that, I don't know, maybe in the area of Bourne, there's more Italian restaurant, because I don't think that's true.
No, but what I will do is to get the best cluster of kinds of cuisines. So I will, what I think I will do is just segment Barcelona with clusters of kind of cuisine. So for example, I will do a cluster that is related to Mexican food. So when the people is around this area, I will know that they are in a somehow Mexican restaurant. And then I will use the method for this Mexican restaurant.
I don't get it, but you could say that if you're in that area, the Mexican restaurants are more popular there. This is what I'm not.
Okay.
Well, you can look for that on TripAdvisor.
But I guess Barcelona is full of restaurants, no? All kind of restaurants everywhere.
Yeah, of course. But if you look for Mexican restaurants, I'm sure I will get a list of Mexican restaurants. And then I will know where the Mexican restaurant is, so I will more or less know where are my cluster of Mexican restaurants. So I will get a list of latitude and stuff from where the Mexican restaurants are.
So you're not like segmenting the city, but.
Okay. You mean
Okay.
not like this, not like squares. No, not like this. I will use just cluster. Yeah, exactly. Exactly. Not fragments of city.
Okay.
Maybe this picture is confusing because it's.
And maybe another option could be if you just get the GPS information and you get, let's say, the 5 closest restaurants in your area. Then if you get the type of cuisine that is served on the restaurant, you can weight your food just with that information. Without having to apply clustering or anything else.
Yes. Yeah. What I also found is another problem. If I use this approach and I am in a shopping center, what can I do? I will know at least that in this shopping center there is 5 kinds of cuisines or 3 kinds of cuisines if I'm lucky, and not all of them. But it's also a problem.
Because of the GPS information will be the same, right?
Yeah, exactly. Because you are in the shopping center and you will get that you are in the shopping center, but in the shopping center you know that there, I don't know, 1 kind of different restaurants instead of I don't know how many cuisines.
And Pedro, which kind of data are you going to work with?
What?
Which kind of data are you going to work with?
No, I will just so why I choose this paper? It's because I want to learn 2 kind of things. Is one of them is not using CNNs for everything. So this is one of the reasons that I chose this paper. And the second reason is because when I look at the pipeline was like nice for me. So that's why I choose it. At the end, I see that I think it's not the good method to apply in my data, because I'm not going to use this kind of data.
But why not? Because you don't have GPS.
No. Because I don't know this data. Well, I can use it because it's built in data, but for now I don't use the GPS data.
Yeah.
When I will use it in the future, maybe I will have these pictures, because it's nice to have pictures with data of GPS, maybe. But what I'm not going to use is this approach.
Okay, is this data set available?
I don't know. I guess the fast food, of course, it is. This one, the PF, for sure it is available, but the other one I don't know.
Okay. Yeah, it should be difficult to get a new data set with a GPS.
Yes. So it could be nice to have it. Yeah.
Even to record it, how could you record the data set? And with a mobile phone.
No, the thing is that when you take a picture, if somehow you allow to the camera to access to the GPS data, each image could have a geotag, and in mainly with all the images that we have, if they have this geotag, we can have the GPS data.
But the dataset we are recording has no GPS data, right? With our camera. Or even if I take a picture with my mobile phone now.
Yeah, I think it has the GPS data.
But where shall I select an I mean, is there an option to?
I don't know. Did somebody try it?
No, because if you are going to work with this thing, we should start recording. And I was just wondering how we could do it.
I think it's automatically, but I didn't look inside the pictures to know where exactly it is. Yeah, but I know what question you are doing, because we should allow, right, to the camera to access to the GPS data.
And also it should be a metadata file or something similar, because the image itself, maybe I don't know, if I click get info from the image, I think I'm not seeing the GPS, so it should be another file, extra file. And I don't know how could we save it? Nothing. Just wondering how we could do it to create a new data set.
I think should be somewhere, but inside the picture, or maybe there is a meta file over there in the picture itself, right?
Yeah.
Okay.
And you can go out to use GPS. You should have it.
Okay. Yeah, I guess so, but I didn't look inside. Yeah. Thank you. So one here says that you will have this data inside the image. I don't know how to get it, but yeah.
Okay. Good.
Thank you. Yeah. Thank you. Cierro la sesión.
Pedro, espera un momento.
Sí, espera, paramos la grabación.